If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
So the first question is, before we get started, the question is, when do we use SAP HANA as a 2-tier architecture, and when do we use SAP HANA as a 3-tier architecture? So I'm hoping everybody is clear as to what makes a 2-tier and what makes a 3-tier, right? A 2-tier is you have a database, and this database is accessed by a client. So the client forms the first layer of architecture and database forms the second layer of the architecture. When a client is directly accessing a database, in such cases, in this case, we are saying that it's a 2-tier architecture. Mike is also saying catalog versus content review as well, please. Absolutely. All right. So in this case, now if we say I'm either using a HANA Studio or a web browser in the place of my client, I'm directly accessing the HANA database that we looked at yesterday, which contains the catalog, content, provisioning, and security. When I'm directly accessing the information that is available inside this HANA database, I'm only leveraging two tools, right? One is my client, and I'm directly accessing the information that is stored within my HANA database. In this case, SAP HANA database is leveraged directly as a database. In such case, it's treated as a 2-tier architecture. But let's assume that your organization, when you go into an organization, they're saying, we have a BW system, which means that BW is the application layer, the software, SAP BW. This application is being supported by an underlying database. Instead of Oracle or SQL Server, they're using HANA as the database. So if you remember our discussion, let's assume that there is an SAP ERP system, which is also supported by some database. Let's assume that in this case, it's supported by a SQL Server database. As and when a transaction hits this ERP system, the transaction gets stored in the underlying database. Because we cannot use ERP system for heavy reporting, the data from here will flow into the SAP BW application, and the data will get stored in its underlying database. Now, if I want to look at this data, if I wanted to access this data, I don't have permission directly to go and look at this HANA database. I cannot use a HANA Studio or a web browser and say, go look at this database and go to this catalog folder and find me the table information. In this particular installation, what they have said is this HANA database can only be accessed via its application layer. So the access to this HANA database, either putting data into the database or retrieving data from that database, is governed by this application layer that is sitting on top of it. Now, if I wanted to view this data, SAP has its own client. Every SAP tool has its client, and that client tool is called SAP GUI. GUI stands for Graphical User Interface. Just another thick client, which means that you have to install it inside your desktop or your computer. And when you log into this client, it will say which application are you logging into. I will give the system credentials to log into this BW system. That internally will interact with my SAP HANA database. You do not, in this case, have direct permission to reach out. You cannot take this client and bypass everything and go directly to your HANA database. Direct access to your HANA database is prevented when there is an application, another SAP application that is sitting on top of it. So in this case, if you look at it, my SAP graphical user interface, the GUI, forms the first layer. The application that is being supported by HANA database forms the second layer, and the HANA database becomes the third layer. So whenever there is an application layer in between, then in such cases, we will use SAP HANA as a 3-tier architecture. Did that explain your question, Fred? If you could give me a yes or no, perfect. All right. So hopefully everybody is clear with this concept of when SAP HANA is used as a 2-tier system or a 3-tier system. Now, going to Mike's question, Mike wants me to quickly do a recap of the folder structure within SAP HANA. So if everybody remembers, when you successfully log in into a HANA database, assume that you're using HANA Studio and you got connected to this HANA database. How did you do it? Using your system credentials. You provided the server name or the host name. You provided the instance number. You provided your user ID and password. When you did that, you got successfully established. You established a connection to your specific HANA database. Now, when you expand this, you're going to see 4 different folder structure. The first one is a catalog. Catalog is nothing but if you imagine this is your HANA database. It could be a big box. It could contain 1 terabyte of memory. Now, all this 1 terabyte is not going to be freely available to everybody, right? So they have to allocate space. The administration, the database administrators, one of their primary function is to effectively utilize this 1 terabyte of memory. Now, your project is saying that in your organization, I'm going to bring data from SQL Server. I'm going to bring data from Oracle. I'm going to bring data from any other system. It could be a mainframe system, whatever it is. If your project is going to bring data from all these different systems, it makes sense for you to, when you bring the data from individual source systems into SAP HANA, one way is to just randomly throw a table from here. You take a table from here and you throw it inside HANA. You take a table from Oracle and you throw it right next to this. You throw a table from mainframe and throw it right next to it. You can just randomly throw the tables into your HANA system. But then there is no organization, right? There is no clear demarcation between what are SQL sourced data, what are Oracle sourced data, what are mainframe sourced data. You cannot differentiate it. In order to help you differentiate and keep that demarcation clear, SAP HANA has come up with a process saying that I'm going to give you a folder structure called catalog. Here is where all your database objects. So far, we understand that one of the database objects that we commonly talk about is a table. Let's keep it clean. Let's not worry about the other objects that are available. For the time being, let's assume that when I say database object, tables are going to be stored within my catalog folder. But before I can throw them randomly inside my catalog, I want to create something called as a schema within my catalog. A schema, think of it as a logical partitioning or a folder structure within my HANA database. So I'm creating a logical partitioning. I will say this particular will hold 200 GB. And I'm going to create a name called schema underscore SQL. So the administrator will create saying that out of my 1 terabyte memory, I'm allocating 200 gigabytes of space within the HANA database. I'm creating a folder structure called schema underscore SQL. The intention of this particular 200 GB space is to bring data from my SQL Server database and bring it here. So now all associated SQL Server database tables and database objects can be brought over and stored here. So now I have a clear demarcation. All my SQL based source system tables and database objects will reside in its own space. Similarly, I would go ahead and create another, let's say 100 GB, and I would say schema underscore Oracle. And here I would bring my data for Oracle related database objects. So the catalog helps me clearly demark the information coming from multiple source system by creating a schema object. A schema object will help me differentiate what kind of information is stored, and within each schema, so I can have a schema for SQL, I can have a schema for Oracle. When I expand it, you will see a set of objects, database objects like tables, and then functions, stored procedures, so on and so forth. And whatever table, if you had brought table A, table B, table C, and table D from a SQL Server system, when you expand this table, it will show there is a table called A, there is a table called B, table called C, and table called D under this particular schema. So now you are within the schema called SQL. When you expand the table section, you understand there are 4 different tables that are stored here. Is the information clear so far, Mike? Just as to what we are talking about catalog, the intention of a catalog is to hold your database objects. Just we cannot randomly throw them inside a catalog. So you define a schema for appropriate source systems and you collect those relevant tables or database objects under that particular schema. So here is where a schema is where all your database objects is going to be. If you brought a table, the table information is persisted. When I say persisted, if there are 100 rows in a table that you brought in, let's say table A has 100 rows coming from SQL Server. If that 100 rows corresponds to, let's say, 10 kilobytes of information of space, this table A is going to occupy 10 kilobytes of space within your HANA system. Totally, there are 200 GB allocated initially for SQL schema. You have occupied 10 terabytes. So physical persistence of that table is going to happen within your catalog structure. Now that I have brought in my individual tables, I go to the content section. The content section is where all your data model or your information models are going to be created. Again, a data model is not a physical object. It is an abstract object. It's just showing how to connect different tables from different schemas to bring about a complex reporting solution. So again, just like within catalog, you cannot directly throw your database objects. If you have models that are specific to certain subject area, let's say I want to create several data models that are finance oriented. I want to create several data models that are sales oriented. So the first thing that you would create within a content is called a package, just like a folder structure. And within that folder is where you would create, let's say, I will create a finance based GL, general ledger data model. I'll create a finance based accounts payable data model, and so on and so forth. All my relevant finance based data models can be created and stored within this particular package called as finance, and so on and so forth with the sales. So now when I create a finance GL model, I probably brought in data from, let's assume that I brought table A from SQL Server. Let's call it GHIJ. I brought G from Oracle, and let's say I brought Z from SAP, and I brought F from another mainframe system. I'm connecting them through some kind of a logic. And now I have created this data model called, let's call this as finance GL data model. Now, where does this data model reside? It will reside within this package called as finance under the content folder. I have created this GL model. But because I am bringing tables from multiple schemas, it doesn't mean that now I have taken a copy of this 100 records and brought this table's copy again duplicated over into my content section. That will not happen. Whenever a model is being created within my content, within my package, it will only refer to database objects in catalog folder. It will not duplicate your data. So this is something that it's just a point or a reference. All right. Hopefully that helped recap the information, Mike. So there's a question from Frank. So when there is a layer in between, it makes 3-tier. Absolutely correct. So when there is an application layer like SAP, ERP, SAP S4, SAP BW, SAP CRM, any SAP application comes in between, then in that case, it becomes a 3-tier architecture. So Fred has another question. What happens to data compression in SAP HANA at this point? Naturally. So what will happen is, see, traditionally SQL Server systems store data in a row format. So what happens? If the 100 records each has a value for year as 2020 or 2021, it's going to store 100 repetitions of the value 2021 in the row format table, right? But let's assume that in this case, this table was 100 records, but the storage space was, let's say, it was 25 kilobytes, just for understanding. When this table gets brought over into HANA, this table automatically will get created as a column store table. Column store inherently brings that ability to compress your data. If there are 100 repetitions of the value 2021, it will only store it once. So typically what would happen, this 25 kilobytes of tables worth of data, when it gets stored in your SAP HANA system within the schema called SQL schema, it will probably end up being like a 3 KB table or something like that. You will see a significant reduction in the table size. Okay, so that will automatically happen. As long as there is repetition values in your source table, when it gets brought over into SAP HANA, it will automatically get compressed. All right. Kofi has a question. Does the administrator space limit constrain the HANA modeler? Typically, yes, right? But what will happen is there is a concept, Kofi, there is something called as an auto extent. In a database, there is something called as an auto extent that is assigned to schemas. So what will naturally happen is you don't want to be the modeler that should not be stopped or prevented from bringing in additional data, and he or she should not, the modeler should not wait on an administrator to always keep extending the space within the schema. So typically how they would approach it is, if your schema is initially given 200 gigabytes, let's assume, they will say auto extend it by, let's say, 20 GB. They would set a threshold on your schema. They will say if it reaches 80% of the total space, I'm just giving you a number here, auto extend, increase your schema space by another 20 GB. So they would have set auto extend capabilities within each schema the moment it hits the threshold. But there will be a cautionary lookout, right? The HANA administrators will be looking out. And if they see that you had told the administrators, I'm going to be bringing data from a SQL Server system, I think that for the current project, the usage, the amount of data I'm probably thinking, amount of space I'm going to use is probably going to be 100 GB. But being cautionary, I'm adding another 100 GB and I'm requesting you to give me 200 GB. This project is supposed to happen over a 6 months period. But in the first months itself, you see that 80 GB worth of space has been already occupied. So administrators will keep an eye on this schema and check with you and see, hey, you know what? You planned for 200 GB, but within the first month itself, you have already occupied 80 GB. Are you still sure you only need 200 GB, or do you want me to extend it? So those kinds of discussion would automatically happen. But in order to, for the administrators to not become the bottleneck in your process, they will enable this auto extend capability in your schema. Hope that helped answer your question, Kofi. All right. So would you estimate, so Mike, how is schema sized? Is that what your question is? Would estimate your project? Yeah. So schema size, again, it depends on when you start having the project requirements. you will have an understanding. So they will say you're going to be bringing data from a SQL Server system. So typically what you would do, you don't probably know anything about this SQL Server system, right? You would go to that corresponding SQL developer, or you would go to the SQL DBA, and you will say, this is my requirement. Tell me how many set of tables am I going to be requiring? They will give you an idea based on your requirement. If you're going to bring sales information is stored in probably 35 tables. And if I run a quick stats on this 35 tables, I see that it's going to take about 95 GB space. So they will give you an approximate estimate. So taking this information, you will always add a buffer and you will say, can you give me a 150 GB terabyte? Even though you know that 95 GB in a SQL Server database, when it brings it into SAP HANA, it could potentially go into a 50 GB or a 40 GB because of the inherent compression capabilities. But that is exactly how during the project requirements, you would understand and capture that information. When you get to the technical discussions, you would talk to the different source system parties involved and understand what amount of information is going to be brought in and what should be the initial schema space allocated. All right. So Fred has a question: who creates the requirements? Typically the business, right? The business drives these kinds of requirement. They might not know the technicalities behind how much tables are there, but what they would know is they'll say, I want to create a sales report. Based on the daily operational interaction, I understand that sales related information is primarily stored in SAP system. The invoice related information is typically stored in SQL Server system, and financial accounting information is stored in Oracle system. That's the level of information a business user will provide. Then what you will do is, as a subsequent set of requirement, you will bring in the respective source system people involved. You will bring a subject matter expert from the SAP group. You will bring a subject matter expert from SQL Server and Oracle system. And you will say that for the sales report to be made possible, can you tell me what are the different things I should be looking for within the SAP system? Then the SAP subject matter expert would bring in a technical architect or a technical team member from their team and help go deep dive into that application and give you information on what is required. Again, it's not a one-time process, right? It's a very iterative process. You have several conversations, you figure out what is required, and you always keep fine-tuning it. As you find more information, you fine-tune it, and you start pulling in the necessary information. The initial schema definition and the space is all just a ballpark. You start with something, and you figure out what is required, and you can always work with the administrators to either extend it or reduce the schema space that you have asked for. All right. Hopefully that helped answer everybody's question. Sorry, Mike, I didn't understand the question. SAP, did you mean to say HANA? Oh, SAP versus HANA. Did not understand the question. Do you want to explain it to me, Mike? So SAP is the ERP system, right? We are referring to. I'm now talking about either I want to bring data from an SAP S4 HANA system, which is the operational system. Here is where all my transactions are being stored. In this case, the SAP S4 system is supported by a database called SAP HANA. So this is an ERP system. Or I could have an SAP BW system that could be supported by some kind of a database. It could be HANA, it could be Oracle, whatever it is. Let's assume that my source information is either stored in an SAP application-based system. These are called business applications, my transactional systems. And now I realize that I want some information to come from here. All the sales related tables are stored in this database, and I want this information to come along, and I have a SQL application. There are some tables. I want to bring all this information. So you want to create a central repository of all these information, and that is what is called a data warehouse. So now this two-tier SAP HANA database, I have this HANA database, which can be directly accessed by a client, is sitting in my organization. I individually bring different data from different systems and collect it in their own schemas. And that's the difference we are talking about. So when I say SAP application, I'm talking about the OLTP system, the online transaction processing system. In this case, the HANA database is an analytical or a reporting system, which means that it's used as a data warehouse or OLAP system, online analytical processing system. All right. Hopefully that gave you the difference between what, when I say SAP's application and the HANA system. All right. So I know all good questions. We did a little more in-depth review, which is fine, which is not a problem at all. So today what I wanted to do is I wanted to talk about one more thing. So I showed you yesterday when we did the look and feel, I showed you how to access SAP HANA system from a SAP HANA Studio client. We also mentioned there is another client which you could use, which is nothing but your web IDE or essentially your browser. I will also go in and log in and show you how to log in into a HANA system through a web browser. Now, in order to, wherever you go, whichever project, whichever organization you go to, if you want to connect to your SAP HANA system, let's assume that here is a HANA system. Is everybody now kind of familiar, at least understanding how? You probably have not done it yet, but is everybody understanding how you would connect to SAP HANA through a SAP HANA Studio? Can you quickly give me a yes or no, please? Is everybody at least theoretically comfortable, if you're given an opportunity, how you would go and connect to a SAP HANA system through a HANA Studio? Now, similarly, if you wanted to do that same thing, you wanted to establish a connectivity to HANA system, but through your browser, the URL or the information that you have to type in your browser is going to be very, very standardized. How you would do is, no matter what your organization is, if I wanted to log in into my HANA system, what are the system credentials I need to know? My system credentials are, I need to know the host name or the server name. I need to know my instance number. And I need to know user ID and password. Is everybody comfortable with this information? These are the 4 critical parameters that you need to know to access a HANA system. Your browser is no different. Your URL is the template of an URL for any organization. No matter where you go, you will use HTTP or HTTPS. Depending on the typically when you go to an organization, it would have an S, which means that the URL, the web browser is secured. That's what that S stands for. In our training system, because it's a training system, it doesn't have that S. So I will just put that within brackets, saying that depending on whether your organization has secured port and not, you can use S or you cannot use S. So HTTP / the name of your host, the host name. This bracket, which means that you have to replace this with your actual host name, colon, port number 80 followed by 2x, which means this x represents your instance number, /SAP /HANA /IDE. IDE is nothing but integrated development environment. No matter which organization you work for, if you replace this host name with your actual. So in this case, what will happen? Our host name is called HANA box .80 and my instance number, if you remember from yesterday, it was 01. That's it. Everything else brings the same information /SAP/HANA/IDE. If you log in, it will ask you for a user ID and password. You enter that information and you will be connected to SAP HANA. All right. So let me take a quick second and I will move on to the other screen and I will show you how to access this web browser and show you the look and feel of your SAP HANA system from a web browser perspective. We have seen how you would get connected through a HANA Studio system. If you were to connect through a browser, any browser, just click on the browser and let's type in HTTP. In this case, because it's going to be a training system, it doesn't have that secured socket. So I'll just go ahead and say HTTP:// my host name is called HANA box :80 is always the prefix for my port number when you use a URL, and then my two-digit instance number 01/SAP/HANA/IDE and hit enter. So if the URL correct. So if your organization, if your location, if you were trying the training system does not have that secured socket layer. So that's why it's not secured. So you have to use HTTP. But if in your organization, you have the secure socket layer, HTTPS will work. Okay, it depends on how it has been configured. So I will give my user ID and password. And if my connection is successful, the initial screen, whatever the 4 folders that we talked about, right? The catalog folder will contain both catalog and provisioning information because they are closely related. Editor is nothing but your content pack folder. Security is your security folder. Traces is for the administration. So if I go click on one of this object, which is the catalog, so just like what you saw on the HANA Studio, can you see that catalog folder and provisioning folders are now showing up? There is this navigation pane and here is my workspace. If I expand the catalog, I will see the list of schemas, all the schemas that we saw yesterday. We created some of these, right? Best_1 and then some HANA, SAP HANA SQL and HANA Oracle schemas. And let's see, somebody had opened this, so I'll try. And if I go to the table section, I right click on any one of the table. Can now everybody see the icon a little more closer? In this case, the icon highlights the column. And in this case, the highlight is on the row fashion. So which means that this is a row table and this is a column table. I can right click a table and say, I want to look at the definition, which means it will tell me about the tables, the type, the fields that are available in the table, the data type, how much length it has, which one is a primary key and things like that. And I can also right click on the table and say, go to open content. If I click on it, it will take me to the data content, the actual data within the table. And here also you have, if I want, let's say, I can click on the SQL editor and I can write a statement. So I can write a statement like yesterday we created a schema. I'll say create schema, let's say best_2. I'm just showing you. And then I will execute it. Execute it successfully. And then if I do a refresh on my catalog again, it should show me that a new schema has been created. There's a question from Mike. Show row versus column again. Absolutely. So if you go to a right click on this table and go to open definition of a table, on the top right corner, do you see that it says it's a column table? This is one way to identify what is the type of the table. Or if you closely look at the icon right next to this table name, the highlight is on the middle column. Do you see that it's the borders of that column is highlighted? That quickly notifies that this particular table has been created as a column table. If you look at this particular table has the highlight on the column, or I'm sorry, on the row. If you can look closely, you will see that the highlight is in the middle row. And you will see on the top right corner that this table has been created as a row table. Got it? All right. So I have some good, interesting, important SQL statements that you can play around with, which will help you in the basics of creating. See, if I ask you to create a table now, you probably, let's assume that we created this new schema called best, and I want you to go ahead and you have to create a new table with hundreds of columns in it. Knowing what you know now, you probably would go right click on this table folder within that particular schema and look for information. You will say, what can I do? What is the information? So let's assume that I go to an existing schema, and in this particular, so one of the things that you will not be able to do is if you go to the HANA Studio, if I go to the schema called best one or best, and I expand this table section, even though there are no tables, I can right click on it and I can say I want to create a new table. There is a graphical user interface method of creating my table. But when I go to the browser, when I right click on this table option, it doesn't give me the ability to do that create new table. In this case, you can only open a SQL console, just like the SQL editor, and you can write a create table statement. If you want to create a column table or a row table, you have to specify what is the schema name. In this case, the schema name is, let's say, best dot. Let's call table as test one table. I'm just creating some table here. And then I will say, I want this particular table to have the following fields. The first field is, and I will give you the statement for this. Don't worry about it. I'll say I want to create a field called ID. And I'm going to make it as, one second. I will make it as integer, comma. I'll say name, varchar 30. And I want to make, just bear with me for a second. I'm just showing you an example. Primary key is going to be my ID field. And now that I've created, I'm saying that I want to create a new table called test1 under the schema called best. This table is going to contain two fields, ID and name. ID is of the type integer, name is of the type varchar, which is nothing but a string. I'm allocating 30 spaces for it. And I'm saying primary key of this table is ID. And I will go ahead and execute this. It says incorrect syntax near on line 5. So I don't need. If I only had multiple primary key, then I have to do that. So let's try it again. Incorrect syntax near line. Just a second. Oh, that's what it is. Primary key. Yeah. So now I think I should be good. Just a second. Okay. So it created a new table. Now you can see that automatically when I ran this SQL statement, a new table got created. If I go to the definition of this table, it says there are two fields, and I didn't, because I specified that it is going to be a column table. You can see the table has been created as a column table. It has two fields. These are the data type, these are the lengths for it, and first field ID has been created as a primary key. If I right click on it and look at the open content, I have not loaded any data into it. So let's load maybe a couple of records onto this table. The statement for that is insert into table values, and I will say, because ID is an integer, I will say 1, comma, name is, let's say, because it's a string, I have to put it within single quotes. And I will do the same thing, insert into. I can just drag the table name here and it will bring along the schema name with it. And I will say values 2, comma, 10. I will select these two rows. And execute it. So if I go back to the table and do a, this is my refresh. Just a second. So if I go refresh and open the content for this particular table, you will see that those two entries have been created. Now the question is, now that I have created a table, and if I go to the definition of this table, I can see it is created as a column table. Yesterday, I promised you that I would show you once a table is created and if it contains data or not contains data, how can I convert it from one type to another type? Let's try that. So there's a simple statement for it. The statement is alter table. If the table is already in column format, all you have to just say is row. I'm simply saying alter this table, which was originally built as column. I'm converting it into a row format. I'll just select this statement and execute it. It says incorrect statement. I think alter table. And it completed successfully. Now, can anybody see the difference? What happened to the icon of this particular table? It went from a column table to a row table. To confirm that, you can go click on the definition. Let's do a refresh. For some reason, I'm not seeing the refresh icon. Let me go look at the open definition. Can everybody see that it has now converted? Yeah, I will show that real quick, Mike. So, but is everybody clear as to how I converted a table even though it contained data? I converted it from a column table to a row table. Similarly, if I wanted to go back and do it again, now the table is already a row table. I can just go ahead and say I want to bring it back to a column table. Select the line, and if you see this green icon on the top, it will execute it, and you see that the icon has gone back to its original. And I can, if I go to the definition of this table, I will see that it has now become a column table. Does that make sense, Mike? Is that what you were looking for as to how you would execute a command? Perfect. Vijayata has a question. Can we check how much memory row table is occupying versus column table? Very good question. So again, when you go to the open table definition, you will, in this particular, if I go to indexes, there are no indexes. So to see some additional information about the table, you would want to do it in the HANA Studio, because HANA Studio gives you additional information. Let's go here. Now that I've created a new table under best, let me go back to this and then go to tables. And we created this new table called test1. Let me go right click and go to open definition of this table. Because we have only loaded one record, you're not going to probably see too much information here. It says that total memory consumption is 44 KB. Number of entries is 2. Size on the disk. See, memory is only occupying 44 KB. But when it is stored in the max DB, it is stored as 284 kilobytes. Can you see the compression factor right here? When you go from a disk-based system to a memory-based system. Okay, this is the information you would see. Because this table has only one record, you are not going to see any difference in the consumption if I convert it from a column store to a row store. But let's try that, right? Even though it's not going to make any difference, I will just execute that command. I will say alter table, and I will convert it into a row and execute it. This I'm doing it in the, I have to establish a connectivity. So this SQL screen was not connected to any database. So I'll click on this database and open up the SQL editor. So now it is connected to that database. I'll say alter table. And then I will say, make it a row table and execute it. Now that the table is executed, if I do a refresh on this table, let's quickly do a refresh on. You should see that that table goes from a column store to a row store format. And now let me go to the definition of this table. Let's do a refresh. Total memory consumption and this one. So in this particular case, it is showing a difference because, let me see what happened. What was the data here? So there are two records. In this case, because they are both unique entries, there are no process of compression needed. It is showing the value as different. I'm not sure why it's showing it this way. Why it was more on the, let's try it again. But these are good information. So thanks for asking that question. So let's make sure that everybody understands what is happening. You will probably not see a big difference because of there is only two rows here. So apparently in this particular scenario, for these two entries, which are completely unique, it is showing that the memory consumption for a column store table is more when compared to the row table. But trust me, when your volume is increased and there is ability for compression, column table always beats the row table. Okay, so that's the information I wanted to share. And then I will also, in the learning management system, I will go ahead and paste this information. There is, let me see if I can copy the whole thing. I will put this so that you have information. These are some of the common. Felix has a question. Is there an alternate in creating tables aside the SQL method? Yes. In the HANA Studio, you can just right click on the table and say, I want to create a new table. And you can give a table name. Let's say test2. And then it will automatically create it as a column store. Right click if you can choose column store or row store. And then you come back here and you can type in individually ID, name, and so on and so forth. You can do it this time. There are other methods also. When we get to the data provisioning, there are much more easier ways to do it. Because we are now taking baby steps, I'm just showing you what are the fundamental ways of creating a table. You could at this point either use a SQL editor to create your table, or you can do it manually through the graphical user interface. You can just right click on the table structure and you can create the table. Again, I will post this information, how to create a table, how to view the table's information. What are the statements you would do? How do you convert a column table to row table, a row table to a column table? And then how will you, if you already have a table and you want to add a new column to the table, how will you do that? If you want to add more than one new column, how will you do it? How do I alter a table statement's data type or length? So I've given you information on that. How do you add a primary key? How do you add many primary keys? How do you drop a primary key? How to completely drop a table? How to rename an existing column? All this information, you can try it out. I've given you an example of how to do it. You can play around with it. Vijayata has a question. Does Web ID also have different perspectives, just like HANA Studio? Yes, it does. So typically what will happen is it won't show you the perspective, but what you can do, you can go from, if your user ID has only modular capabilities, you will not see the other functionalities. Let's say, for example, you will be able to see the catalog and you will be able to see the editor, which is nothing but if I flip to the editor, it will now show me the content folder and the packages underneath it. The only difference you will see between a browser and a HANA Studio is you can, let this open up. You will only in a web browser, you will only see whatever you're limited to see. So you can now see all the packages and underlying objects, underlying data model. I'll just show you how a data model would look like. Let's see if somebody has created anything. Let me. This is how a data model would look like. When we get to data model, we will be creating such data models. You will be doing join conditions, so on and so forth. All that will be happening here. So to answer your question, Vijayata, what will happen is, depending on what kind of access your user ID has been provided, you will have access to catalog and editor. Typically, if you're a modeler, you will have access to these two. If you try to go to a security object, if your access did not permit it, it won't even open up the screen. It'll just throw an error saying that you don't have permission to look at the users. But on the contrary, in the HANA Studio, you will always see these 4 folders here. But if you expand this, it will show you this. But when you expand here and you try to click on something, it will throw an error saying that you cannot do it because you don't have permission to look at the security information. Mike is saying I may need help. Yeah, go ahead. Let me know what your question is, Mike. Let's see if we can help you out. Now, let me share the other screen. And the other information that I wanted to discuss for today. Before I move forward, let me see if there is a question. Okay. I'll wait on your question, Mike, and then we'll take it from there. The next thing I wanted to discuss is another topic is SAP HANA Technical Architecture. As I mentioned yesterday, this is nothing but going under the hood of your vehicle and figuring out what happens. Mike is saying, I've never worked with database SQL. No worries. As we progress, right, you will get familiar. And again, I'm teaching you the fundamentals because you have not still learned the data provisioning capability. When you do data provisioning and you identify a table from SQL Server to be brought over, that data provisioning tool itself will create the table for you in the HANA system. So you don't need to know the SQL process, but whatever SQL statements I have given you is the basic fundamental of how, if you want to do a SQL statement, what will happen. Okay, so don't worry about it. As we progress through, I will give you those specific instructions on what needs to be learned. Okay, absolutely. Yeah. So on the learning portal, on the discussion board, you can ask questions. So between over the week, if you have any questions when you practice, if you have any issues, what you can do is you can post a question there. And by posting a question, everybody in the batch gets to see the question. So if somebody else knows the answer, please feel free to answer the question for the other candidate. And if you're not able to handle it, I will also take a look at it and I'll help answer the questions. Okay. All right. So when we talk about the SAP technical architecture, no worries, Mike. All right. So let's take a look at your SAP HANA system. I'm going to try and divide the system. 1, 2, 3. So there are so many pieces of tools within your SAP HANA system that's making your SAP HANA run smoothly on a daily basis. Even though there are so many servers and services inside your HANA system, there are 4 key things that you need to know. The first one is called a name server. Second one is called pre-processor server. Third is called statistics server. And the fourth one is called index server. So when we talk about the technical architecture, we need to know about these 4 different types of servers that are available. And I will talk about this blank space in a minute. So let's first understand what is the need for a name server in your HANA system. Name server, as the naming itself is giving away, contains the technical name of your HANA database. So it's also called as the system ID, SID number. So our server name is called HANA box, but internally it will have some kind of an identification number, a technical name or an identification number assigned to this particular box. That information is stored in this name server. Why is this critical? Is for people who are administrators to do patchwork or to do upgrades or to do maintenance, they will access the system only through this name server technical name. They will use this SID they won't call it as HANA box. They will use some kind of a technical ID to help identify which particular system are they working on. So that's how a name server is going to be relevant for our discussion. Second one is pre-processor server. A pre-processor server helps with, typically, if I want to process my data that is sitting inside a HANA system, what is the traditional way a data is stored in a HANA system? Not just in HANA, any database. When I look at a table, how is the data stored? Would it be correct to say that my data is stored in rows and columns? If I take a table and I look at the information, would you say that row information is stored as rows and columns? Right? That's how a table structure is, right? It's a combination of rows and columns. This is called structured data. Anytime you are processing a table, you are processing structured information. It has a proper definition. This table contains 5 columns and it contains 200 rows. You have a clear information about what kind of information is stored within this table. That whenever data is stored in a table, the data is referred to as structured data. All databases can understand data stored in a table which is structured, and there is no big deal about processing that information. But nowadays, what's happening? Data is not just structured, right? We are talking about unstructured data. What is unstructured data? data coming from your social media. I can have a Twitter account. Somebody is typing away some information. Big lot free text information is being typed into the Twitter account. Somebody is posting a comment on their Facebook or their Instagram, whatever social media they're using. They are using free text. When they enter a free text, there is no way for me to bound that information in a table. Would everybody agree? Can I take a free text saying that this particular product, I'm writing a comment, this particular product is very good. I've written a comment on my Instagram or my social media. This particular information is free text. I cannot bound it within a table format. So it's now becoming more and more popular as to how to handle unstructured data. Basically, how do I add free text data? Or how do I do text analytics? If I get free text information from social media, how do I process that? The server, which is responsible for processing unstructured data, is your preprocessor server. When we talk about text analytics in our advanced topics, it becomes much more clear. We will understand that how text analytics is prepared and processed. But what is the server that is responsible for dealing with your unstructured data is your preprocessor server. Next one is the statistics server. Nothing big about it. As the name itself suggests, all statistical analysis about your system. This is typically used by your administrators, is going to be done within this server called as statistical server. I might have quickly gone through name processor, preprocessor, and statistical server because they are all important to know, but they are not very critical. What is the heart of your HANA system? If I were to say this is the one thing that is making everything happen in your SAP HANA system, that is your index server. Index server, you can treat it as your heart of your database. Here is where all data is stored and processed. All action within your HANA system relating to data is performed in your index server. This is, think of it as your heart of HANA. Now, HANA initially, when it came in November of 2010, was only treated as a database because they were only looking at these 4 capabilities primarily, and they considered HANA to be a database. But slowly, as it progressed, HANA moved from being called a HANA database to a HANA platform. It is no longer referred to as a database because it does much more than a database. Now, what is different is this particular section. If you all remember, I said there is a native HANA development perspective, SAP HANA. Does anybody remember this concept? I touched upon it and said, here is where you will do web application development. You want to create a new application, you want to create a new web-based application. Let's say you want to open up a shopping cart like Amazon. You want to create a web page completely driven by a HANA database. What you would need? You would need web application development capabilities in that system. So SAP HANA said, if your organization wanted to create a website or some kind of a web application like Amazon, or let's say Yahoo or something like that, or eBay, and they wanted that to connect to a HANA database and fetch all the information. Earlier, what they would have done, they would have gone with some other application like Java or .NET, some kind of web application tool, and that would be integrated with your SAP HANA system. So now you had to rely on a third-party application like Java or .NET to do your web application development. But SAP HANA said that my in-memory database is so powerful Why throw it to an outside vendor to diminish the capability of that database? So they brought in something called as a web application server. They brought in a web application server inside the SAP HANA system. And this is driven by a technology called XSA, Extended Service Advanced. Extended EX, that X comes from the X, Services Advanced. This is an engine that is capable for web development. So they brought in an inbuilt capability for web application designing. So you can directly write JavaScript, JS Node. There are several application programming languages that can be used to directly create this web application right inside your HANA system and tap into the underlying HANA database and fetch the information. So you don't have to go to another third-party vendor like Java or .NET to bring the web development capabilities. So this is why SAP is no longer just, HANA is no longer referred to as HANA database. It's a HANA platform. It can do database capabilities. It can do web development capabilities also. But now, going back to our discussion about technical architecture, technical architecture is referring to what happens inside your index server, the heart of your HANA system. What is going to happen? So let's assume, let's say I have, just a second. Let's assume that I have my client HANA Studio. And this client has established a connection to my SAP HANA system. If you remember, this is the HANA box server, the 01 instance. I have imagined this is my HANA Studio. I have established, let's call it as HDB connectivity. It has established connection to this. Now, when I click on a catalog, I expand a schema and I go look at a table. I right click on a table. Let's say there is a table and I say I want to look at the data. It shows up the information on the workspace. Is everybody with me so far? If I right click on a table and say open definition or open content, what's happening? It's showing me this data. How does this action open content open the data here? How does it go back to your database? Let's assume that the table is stored here. It brings the content and displays it on your workspace. Does it make sense? Is my question clear to everybody? You need to know, when I right click on something and I say open this table's information or create a table, or if I say I open the SQL editor and I write a statement, create table A, and I hit the execute button, how does a new table called A gets created in my HANA system? How does this go interact with the database and go ahead and create a new table in the system? How is this interaction happening between my client and my HANA database? What happens? What goes under the hood? So this arrow, what happens in this place is what we are trying to understand in our technical architecture. All right. So now, if I simply say I have a HANA database or a HANA platform, whatever it is, right? Interchangeably, you can refer to it as HANA database or HANA platform. How can I access? What tools can I use to access this HANA database? Can everybody agree that client is one way to access my HANA database? In this case, the client can be Studio, HANA Studio, or a web browser. Would everybody agree that I can access my HANA database through a studio or a web browser client. If this HANA database is supporting an application like SAP BW or SAP CRM or SAP S4, can I also say that an application can directly talk to a HANA database? An application like BW, S4, CRM, SRM. Is this also a possibility? Can an application also talk to a HANA database and get information and post information, right? Now that I have done all my, either using the client studio or web browser, I brought in the respective tables and then I created my data model. Now I want this data model to be made available to reporting tools. Reporting tools like Web Intelligence, Design Studio, let's say SAP Analytics Cloud. So can I also say that a reporting tool can also access this HANA database? So if I want to broadly categorize them, a client can access a HANA database, an SAP application can access a HANA database, a reporting tool can also access a HANA system, right? So what we are trying to say is, if this is what is happening, whether a client is approaching a HANA database or an application is approaching a HANA database or a reporting layer is approaching a HANA database, how is that communication happening between these clients, application reporting tools along with your HANA database? That's the technical architecture. So let me now take you through the technical architecture. Let's say I'm going to draw a box here. Let's assume that a client like SAP HANA Studio or web browser or an application like SAP S4, SAP BW, SAP CRM, or a reporting tool. Let's, for the current situation, assume that these are the only three possible ways something is going to access my SAP HANA system. And let's say here is this entire box is my HANA system. What we are going to understand is, let me call this as SAP HANA system. What happens when a client or an application or a reporting tool communicates with my HANA box? The first thing that you have to understand is, HANA being a database platform, it can understand two different languages. So if you remember, when I went to this HANA Studio and wrote a SQL statement, create table and so on and so forth, and when I right clicked and said open content and open definition and all that, underneath this is translated into a SQL statement. SQL is, for people who are not familiar with what SQL stands for, structured query language, SQL, structured query language. It's the programming language or the language that any database understands. So when a client or an application or a reporting tool is going to communicate with the HANA system, its primary communication method is SQL. It's going to communicate through a SQL statement, or there is another language called as MDX, multi-dimensional expression. It's a language that is predominantly used by Microsoft products. Many Microsoft products use MDX language to talk to other systems. So two ways a client. So if you look at the HANA Studio or your web browser, they will use SQL statements to communicate with your HANA system. SAP application systems, when they talk, they use SQL command to pass information back and forth to the HANA system. Majority of the reporting tools, Web Intelligence, Design Studio, SAP Analytics Cloud, all that uses SQL statement. If you use a Microsoft Excel as a reporting tool and you want to communicate with the SAP HANA system, Microsoft product will use MDX language to communicate. So the question here is, what are the two languages through which a client or an application or a reporting tool will communicate back and forth with the HANA system? One is the SQL statement, which is the predominantly main form of communication from an outside world to a HANA system. And certain reporting tools uses MDX as a communication mechanism to talk to your HANA Studio. Is everybody good so far? By a quick show of yes or no, please. The takeaway here is these are the two forms of communication or the languages that SAP can use to communicate. That is, a client or an application or a reporting tool can use to talk to your HANA system. Now, when a client or an application or a reporting tool decides, Vijayata has a question, how about Tableau? Tableau has both MDX and SQL capability. In this case, when it is connecting to SAP HANA, it would use SQL statement. Tableau will use the SQL command to communicate with the HANA system. But Tableau also has the capability to do MDX commands within itself. Okay. The moment a communication starts, so let's assume that I am in the HANA Studio. I am connected to the HANA database. Okay, I entered. SQL is better in certain cases when you have to. If I can hold off on the MDX when I talk about the reporting tool Microsoft Excel, I'll explain it a little better, Vijayata, because some people will get confused with it, right? But overall, SQL is better. And there are some exceptions where MDX works better, but predominantly SQL is the preferred language for any databases. So HANA is no different from that. Let's assume that this is my HANA Studio. I have established a connection to my database. I am now writing a statement. I'm saying select star from table A. I'm writing a command and I'm executing it. Select star will just bring table contents. It will show me what is there inside my table. Or I just say right click and say open content. So what is happening? This Studio tool is now sending a SQL command to my HANA database. Is everybody with me? I'm just taking one example to explain how the technical architecture is working. I either right click on a table and say open the table content, or I write a SQL statement in the SQL editor to bring back the information inside that table. So in each case, internally a SQL command is getting executed. That SQL command is now coming and interacting with the SAP HANA system. So now how the SAP HANA reads the SQL command and brings back and shows you the data is the question here. All right. So let's assume that taking this scenario, the SQL statement called select star from table A is coming into my HANA database system. When that command comes into my HANA database, the first layer within my HANA database is called connection and session management. There is a layer within my HANA system. Think of it as a doorkeeper. A doorkeeper is standing at the entrance of the HANA system. Anytime a command comes, whether the command is SQL in nature or MDX in nature, it first hits this connection and session management. What is the duty of a connection and session management is to be guarding the HANA system. The connection and session management, first what it will do is internally, it will authenticate you as a user. It will confirm. I see that user XYZ is asking. Now that I am logged in, let's assume my user ID is XYZ. I am logging in. I've logged in into the system and I executed this command. It will authenticate. Are you a valid user? Are you even capable of being in this HANA system? Are you even capable of communicating with this HANA system? It will authenticate you. In addition to authenticating you, it will also go through a process called as authentication manager. This manager, the authentication process will confirm whether you are a valid user, whether you as a user belongs in this HANA system or not. That's what the authenticate part of it will do. The authentication manager will confirm your role and security. Are you allowed to see information from this table A? Do you have the ability? Do you have the right permission to get information about this table A in your SQL statement? So the connection and session management guards the SAP HANA system from improper authentication, improper access. Is everybody good so far? As soon as I hit a command, a SQL command, or I right click on a table and say open table content, internally this is happening every time. It will confirm whether I am a valid user to use the system, and authorization manager, correct. Authorize is equal to authorization manager, correct. That will confirm, do I have the permission to look in information? Because I could have a private table. I can have a table which contains all salary information and social security information about my employees. I don't want to give access to that table to everybody in the organization, right? It's a private, it's a personal identification table. I cannot give that. So what this connection and session management layer does is, it will confirm if you are a correct user to be in the system first. And if you are a correct user, it will check whether you have the correct authority to ask this question, whatever question you're asking. If in this case, you're saying, I want to look at the table's content, are you allowed to do that? If it confirms that you are a valid user and you have the authority to ask this information, the connection and session management will pass the information to the next layer within your HANA system. And this is called request processing and execution control. Again, you don't have to remember everything here, just the idea. I want you to remember the idea, not every word I'm saying, right? The first layer is called connection and session management. The second layer is called request processing and execution control. Here, there are 5 engines sitting. There is a SQL engine. There is an MDX engine. There is a stored procedure engine. There is a planning engine. And a calculation engine. There are 5 engines sitting within this request processing and execution control. As soon as the connection and session management says that you are authorized and you have the authority to ask for this information, that SQL command gets passed, or the MDX command gets passed to the next layer, called this request processing and execution control. If the incoming communication is SQL in nature, the SQL engine is fine-tuned. The engine, this particular engine is fine-tuned to understand and reciprocate to SQL commands. I'm not sure if everybody knows this information. SQL commands are primarily of 2 types. There is something called as a DDL command, and there is something called as a DML command. The types of SQL statements you can create. DDL stands for data definition language. In a simpler term, what it means is anytime you are writing a statement that is defining an object, I say create table, delete table. When I say, or I say create schema, when I write a statement that is creation or deletion in type, you're defining an object, right? You're either creating a defined new object or you're deleting a defined object. When your statements are create or delete in nature, they are called DDL type of SQL commands. When your DML stands for data manipulation language. DDL creates the table, deletes the table, right? It's at the structure level. I'm creating a new table or creating an existing, deleting an existing table. I'm taking away the entire structure. DML deals with information inside the table, which means that I want to alter the table, which means I have 5 columns. I want to add one more additional column. I want to insert records or delete records from the table. I want to modify the table structure. Any manipulation is going to be a DML type of command. So these are the typical 2 types of commands you can have in a SQL statement. The SQL engine is capable of handling all DML commands. Anytime your select statement, if you can see this, a select statement. So if I say select star from this table, or if I say open content, it's nothing but it's doing a select information. So all DML statements will be handled by this SQL engine. There is another object called metadata manager in your HANA system. This handles all DDL statements. Typically, creating a table, deleting a table, creating a schema is all very administrative oriented work. So if the incoming SQL statement is of DDL type of nature, like creating a schema, the SQL engine will pass it to an object called as metadata manager, and that is what will handle it, because these are engines fine-tuned to deal with SQL commands. If the SQL command coming in is DML or data manipulation language type of capability, the SQL engine will take care of it. If it is DDL type of command, when I write a create schema statement on the HANA system, the metadata manager kicks in and says, the connection manager first will check if you're authorized to do it. If you're authorized to do it and you have the right security for it, it will send it to this request processing and execution control stage of your HANA system. The SQL engine will look at it and say, oh, this looks like a data definition command. It will pass it along to the metadata manager to create that particular SQL command, to execute that particular SQL command. But instead of the SQL command, if the incoming command was an MDX statement, naturally, the MDX engine will kick in and it will say, I will go ahead and process this information. I know how to read this statement coming from the MDX language. I can handle it better. That's what the system will do. Typically, your SQL statements, whether it is a data definition or a data manipulation, they are single line statements. What do I mean by single line statement is when I write a command like create schema, this information is one line. Would everybody agree? When I write a select statement, when I say select star from table A, this is again a one line statement. Generally, your SQL statements are one line statements. You either write a command to define a new object like create schema, or you do a data manipulation language like select statement, or you would say insert values into this table. ID is 1, name is Tim, you write an entry. That's a one-line statement. SQL statements are typically one-line statements, but you cannot always live with one-line statements, right? You could have a project where I have to combine like 200 individual lines of SQL statements and write like a program and execute that. When there are more than one SQL statement involved and there is some kind of a loop logic or some kind of processing that needs to happen, these individual SQL statements are bundled together. They are written as bundled together, and this is called a stored procedure. A stored procedure is nothing but a lot of individual SQL statements combined together in some kind of a logic to work in conjunction. When you have multiple SQL statements brought together as a stored procedure, there is, if the incoming SQL statement was not just individual statement, but it was a body of program that contains like 20 or 30 lines of SQL statement, that gets routed to this third engine called stored procedure, which is designed to specifically handle multiple SQL statements at a time. So it is specifically created for that purposes. If the incoming information, so if you now remember, if you take the case of an application, let's assume that now I'm not talking from a client like HANA Studio or web browser. There is, let's say there is a tool called SAP BW, Business Warehouse. One application within this is called BPC, Business Planning and Consolidation. There is a application called BPC, which deals with a company's budgeting, planning type of activity. So when you do budgeting for an organization, there is a lot of computation that goes. You have to do forecasting, you have to plan for the next year, you have to have different versions of budget for your next year to see how things are going to fluctuate. So there is a lot of planning calculation that goes into play when you use a tool like business planning and consolidation. Now I'm talking about an application. So I go into one of the application called SAP BPC, Business Planning and Consolidation, and I want to do some kind of I'm asking for some planning type of activities to be performed. It will turn into a SQL statement and it will come inside the system. But now the system understands that the source application requesting this command is a planning system. It's a planning tool. What it will do is there is a separate engine created for handling planning type of activities. The planning engine will kick in and say, I know that even though it is a SQL command, but it is coming from a planning tool like SAP BPC, I have the capacity to handle planning questions and calculation. Pass that information, route it to me. I will do the necessary activities. I will process that information efficiently. That's what the planning engine would do. And Mike, if you remember, when we were talking about the what and how of SAP HANA, if you remember, we talked about a push down mechanism capability. I think it was Mike who asked me this question. You asked me how the other databases are not able to handle the calculation and it has to push all the information up to the application layer. And why HANA alone is different? Why is HANA capable of doing all the calculations without sending the information up into the application layer? That is because of this calculation engine. This calculation engine is not a typical engine that is available in every database. This is specifically designed for HANA when you have complex queries coming in that needs to create all these dynamic calculations. Like if you remember, for a sales, I want to calculate the tax associated with it. This calculation engine is designed to do all that. What would have been typically done by an application layer in a traditional database is now incorporated in this calculation engine, and the calculation engine takes care of processing such complex calculations without sending back the data to the application layer. So these are the 5 engines which appropriately, depending on what kind of information is being passed through the connection and session management layer, will pick up that information and start processing it. Now, once a particular engine has picked up the information, whether it is SQL command or MDX command, it will take that information. Now it will say, okay, you have sent me a select star from table A. Let's assume that that's the SQL statement that came through. That SQL statement comes into the session connection and session management, agrees that, okay, you as an user has been authenticated to be in the system. And I see that you have the authority to do a select star, or which means that you want to be able to see the contents of this particular table. There's a question from Mike. How or what decides routing of a task among these engines? Which I just explained, right, Mike? Depending on what kind of a SQL command you're passing. If the command was a select star, which means that it is a data manipulation type of language, automatically the SQL engine knows that. It will automatically pick up that information. It is designed to look for all data manipulation language type of statements, and it will pick it up. So each engine is pre-tuned to catch the respective type of so let me see if I can is this helping? I'm trying to minimize the screen. Let me know if that is perfect. Okay, so they are pre-tuned, Mike. They know exactly what kind of information is coming through, and it can capture that information and start processing it. Now that, let's assume that the information asked was a simple data manipulation statement. I want to open this table and see the content of this table. That's what a select star from a table represents. So the SQL engine knows that, okay, you have sent me a data manipulation type of command. I'm going to process it. What is going to happen? It will take the information, the command that has come, into the next layer. This is the relational engine. Hopefully everybody can read my handwriting. Or the memory of your HANA database. What's going to happen is, what are the two different ways a table can be created in HANA memory? Anybody? I can either create a row table, or I can create a column table, right? So in my SAP HANA memory, there are only two different types of tables that are available. Now that I have got the select star table from table A information being routed from the connection manager to the SQL engine, the SQL engine now understands that this table A, let's assume that it's a column table. It was created as a column table. It will route that information to the respective column table stored in your memory and fetch the information and send it back to the user, to the output. If the information you're asking is on a row table, that SQL would have routed, engine would have routed it to the corresponding row table to fetch the information. But let's assume that instead of, if it was just seeking information to see what is available in the table, in the example of the select everything from table A and show it to me, the HANA Studio, I wrote the SQL statement. It came to the connection and session management, got authorized, it sent it to the request processing and execution control layer. The SQL engine picked it up, saying that it's a DML command, data manipulation language command. Send it to the appropriate column table, collect the information, and pass it back to my HANA Studio. That's how I see the final output. Is everybody with me so far? As part of these three steps, the connection and session management and the request processing and execution control, and getting routed to the relational engine or the memory place within HANA, I was able to now see the information for my question. Is everybody with me so far? By a quick show of yes or no. If I simply went to HANA Studio and I said, hey, you know what? I want to right click on a table and say, I want to see the content. That internally got represented as a SQL statement. That SQL statement went through the connection and session management layer and said, okay, this person is authorized to ask for whatever he or she is asking. It will get routed to the request processing and execution control. The appropriate engine picks it up. In this case, because I'm simply asking to view the table, it understands the SQL engine can get the work done. The SQL engine takes that information and goes to the appropriate column table or row table stored in the memory and fetch the information. On the contrary, if I had a table called A and the table was empty and I was writing an insert statement, I want to write there is ID and there is name, but the table is empty. I want to enter a value called 1 Tim 2 Tom. I'm sending an insert command, an insert statement to write data into this table. I'm now pushing a record into the table. That insert statement comes from our HANA Studio. It's a SQL statement, goes through the connection and session management. SQL engine identifies that it is still a data manipulation language, because if you remember, the insert statement is part of my data manipulation language. It says you are trying to write to a table that is column in nature. So it will bring that record and write it into that particular column table. Now, the data has been written into the memory of this table. Within the HANA memory, 2 records have been inserted into this table. But is it sufficient if I leave the table entry just to remain in memory? What is the problem if my data stays only inside the memory? So far, all the process is working. I got a command to write 2 new records into my table, and I was able to route it through the perfect engine, which is good for the work, and I was able to load that information into the memory. Exactly. Mike is saying if there is a disaster or some kind of a power outage happens, all the data that is stored in my memory, whether it is a column table or row table, everything gets wiped off. So you need to back up the information. So the HANA system, as and when data is stored in your column table or your row table, depending on the command you have got, it will further push it into the next layer called as the persistence layer. This is the max DB portion of your HANA database. It contains a object called data volume and a log volume. Corresponding to this data volume is something called as a data disk. Corresponding to your log volume, there is something called as a log disk. Now what happens? Frank has a question. What about if it is overloaded? I mean, the system will be designed such a way that there is enough memory for it, right, Frank? You will never come across a scenario where you outgrow the size of the system. The administrators would not let it happen, correct? They will always plan for it in advance. If they have to extend the database size, they will go ahead and do it. So the memory will never get overloaded. It will always be used in capacity, or they will increase the capacity. Now, what happens typically is when a table, or whether it is a row table or a column table, gets data loaded into it, as soon as the data has been successfully loaded into the memory table, what happens is there is a concept called as save point, or people who are familiar with database technology, there is something called as a commit. This is a configurable functionality. You can say that every 1 minute or every 5 minutes or every 10 minutes, this is very configurable. The administrators can say every 1 minute a change happens inside your memory. Push that change into the persistence layer. It will have some kind of a configuration saying that every 1 minute, figure out what changes has happened to a row table or a column table. If a new entry came in or an entry got deleted, somebody wrote a delete statement and deleted this record called to Tom, they wanted to delete it. Anytime in that 1 minute time period, whatever changes happens, take that and write it into this data volume. So the data volume will contain all data changes information that happen. So let's say I have a time interval here. Let's assume that now is 10 a.m. We are saying that, let's say the save point or the commit is set for 5 minutes. Every 5 minutes, which means 10:05, 10:10, 10:15. Let's assume that this is my memory. At 10 o'clock, somebody loaded 100 records. It'll keep loading this in memory. This 100 records is now in memory, but the associated persistence max DB does not have this 100 records yet. At the time it reaches the 10:05 mark, it's an autosave. Exactly. Just like your autosave, it will understand whatever is happening. Whatever changes has happened between 10 and 10:05, one table A got 100 records. Table B got 5 records added. It will keep track of all this information. At the 10:05 mark, it will take all those changes, 100 records for table A, 20 records for table B, and it will push it into the data volume. It will say, between the last 5 minutes, these are the changes that have happened to multiple tables, and it will push it into the data volume. This keeps tracks of all data changes that happened within that save timeline, which is 5 minutes in this example. You might ask me, what is the need for a log volume? Let's say at 10:05, it started table C, a new table C got 5 records added. So it is in the memory, but has not reached my persistence disk, which is my max DB. At 10:04, or sorry, let's say 10:09, a power outage happened and the system went down. Now, can you tell me what happened between 10:05 and 10:09? I have loaded 5 records or 50 records into my table C, which is in memory, but not has reached my persistence layer. At 10:10 is when I was planning to push these changes into my data volume. Is everybody with me? By a show of yes or no? At that stipulated 5-minute interval, I would have captured all the changes that happens in the memory and push it into my data volume. But before that 5-minute interval could happen, let's say at the 4th minute, 1 minute short of my next commit happening, the power outage happened. So what happened? Anything between 10:05 and 10:09, I would have eventually lost it, correct? Because it was not committed into my persistence layer, I have a possibility to lose that information. So in order to avoid that complex possibility of losing your data, whatever happens between your commit interval, between that 5 minutes, is immediately captured. So at 10:06, if 5 records entered, the log volume keeps track of whatever happens between your commitment interval. The log volumes will keep track of, okay, this minute, some changes happen to your table. I'm going to keep track of that, with the hope that if something goes wrong and my system goes down, the log volume is temporarily holding that information. Now, if that was the case, if table C had 5 records loaded within that 10:05 to 10:09, the log volume is now keeping track of that 5 records loaded into the table C. At 10:09, my power outage went through. When I bring back the system, when I power it up, what is going to happen? The data volume will say, from 10 to 10:05, I knew that there was table A had 100 records, table B had 50 records. It will push it back to the memory. It will say, I am giving you back all the information I had saved so far. Table A had 100 records, table B had 50 records. And log volume will say, even though you didn't commit it and keep track of it in the data volume, Between 1005 and 1009, there was also another change in table C, which contained 5 records. That also will get pushed into the memory. So by having this data volume and log volume combination, SAP HANA is guaranteeing that you will not lose any data through the crack. It would either be committed and saved in your data volume, or it would be temporarily stored in your log volume between your commitment interval. And data disk is nothing but your hard disk that stores your data volume information. Log disk is nothing but your device, your hard disk that stores your log information. All right. Does it make sense? So this is the technical architecture. When I go into the system and right click on something and say open definition or open content, a SQL command is internally getting passed into this system. And these are the different engines that picks over the information and talks to the relational engine. Can you also notice that none of these 5 engines can talk to a persistence layer? It can only talk to the memory layer. Because if you remember, I mentioned during our earlier discussion, you could think of the persistent layer being a duplicate, but I ensured you that the persistence layer is only to keep track of backup for a disaster situation. No engines within the request processing and execution control can bypass the memory layer and go to the persistence layer to bring the information. It can never do that. It only has access to the memory layer. Mike has a question. So data moves from log volume into data volume. No. So what will happen is, very good question. So let's assume that between 1005 and 1010, table C had 50 records added. Let's say at the 1007 mark, timeline mark, this happened. And at 1009, let's say the outage happened. So whatever happened between these two is captured in the log volume. And when you power start it, it will push it back. But let's assume that the log volume kept capturing whatever was happening between 1005 and 1010. And no power outage happened. A commit happened at 10 or 1010. What will happen? All these changes to the table C with 50 records now gets captured here, and the log volume will get wiped out. It will say that there is no need for me to anyway keep the log volume, because now the committed information has moved on to the data volume section. Now I will start all over again. The log volume will get cleaned up, and yes, it is a temporary storage until the committed data gets pushed into the data volume. The moment the C with 50 table entries moves into the data volume, log volume will get wiped out clean. It will start again and say, exactly, until committed, it will keep track of that information. The moment a commitment has happened, it will start afresh and say, okay, from 1010 to 1015, I'm going to keep track of what's going to happen. And the process will repeat itself. All right. So this is what I wanted to cover from a technical architecture standpoint. Does it make sense for everybody? Again, the reason why I explained this technical architecture is you might not be using this information on a day-to-day basis. Tomorrow, when you go right click on a table and say open content, I'm not expecting you that you visualize how it is getting passed to a connection in session manager, how it goes to the request processing and execution control, how it goes to the memory level and talks, and how is it persisted within the MaxDB component. The intention is, if you aspire to increase your level of competence from HANA modeler to you want to become a HANA architect, or you want to become a senior modeler, or you want to become a subject matter expert, it is critical that you understand the technical architecture. Because if somebody questions you what is going on within the system, you are able to have a command over the subject and say, this is exactly how the system will interact internally. Okay. And these are some of the things that you can showcase when you talk to a person during your interview. You can explain these are things only people who have worked on the SAP HANA system. This is not a knowledge you can read through a book and say, this is how the architecture works. These are things you will understand when you work on the system for an extended period of time. That is why I wanted to explain it so that you can showcase this during your interview process and your conversation. When you get into a project and you are working with senior people, when you know these information, you establish the credibility that you are an experienced HANA consultant. All right. So this is the last topic that we have for our first block of information, which is the foundational block about general. So we have learned a lot about SAP evolution. We have talked about how SAP products came into the market. How did we eventually end up with a product called SAP HANA? What are the technologies behind SAP HANA? We talked about Trex. We talked about P start time. We talked about MaxDB. We specifically went deep into the Trex capability to understand what are the functionalities that are helping SAP HANA process much faster than its competitors like Oracle and SQL. We looked at row versus column format capability. We looked at the massive parallel processing functionality that SAP HANA brings. What is the push down mechanism? We looked at all that, and then we understood how SAP HANA could be deployed in any organization. It could be done through an on-premise capability, or it could be done through a cloud. We saw what are the different possibilities within an on-premise situation. What are the different possibilities when you go into a cloud scenario? Then we started looking at the HANA look and feel. What are the different clients we can use to access a HANA system? We looked at how to use a HANA Studio, how to establish connectivity to a HANA database from your HANA Studio. Today, we also looked at how to connect to a HANA system through a web browser. We understood what are the 4 different folder structures. Though we didn't go into all the 4 folder structures, we understood what are the catalog folder, therefore, what is the functionality of a content folder. We looked at that, and then we finally wrapped up this foundational block category of information by looking at the technical architecture. What is happening in the system? What are the processing? How is the communication happening either from a client, from an application, or from a reporting tool? How is the communication going back and forth with your HANA system? All right. Hopefully the information covered so far was beneficial and informative. Can I quickly get a yes or no, please, with the information we have covered so far? The plan is from next week onward, we will start with the next group of information, which is data provisioning. Very, very critical information. How do we interact with different source systems, and how do we bring that information into SAP HANA? We will look at 5 different types of data provisioning tools that are available. We will go into depth of each one of them and figure out how to efficiently bring the data from different systems and store it in the SAP HANA system. All right. So maybe the next 6 to 7 sessions will be purely focused on data provisioning, different types of data provisioning, and how to bring the information into SAP HANA system. Perfect. So Mike is saying repeat provisioning again. Provisioning is nothing but how do I connect the HANA system to any source system like SAP, SQL Server, Oracle, whatever it is. How do I establish the communication? How do I identify a table and bring that information over to SAP HANA? And how do I load that information? That's the process called data provisioning. And I will start the discussion next Saturday by explaining how that concept works, the concept of ETL, extraction, transformation, and loading. And that's how I'll slowly introduce you to, I'll take you from a simple technique of data provisioning to the complex provisioning methods. Okay, I'll take you through step-by-step process. All right, that's what I wanted to cover. Thanks, everybody.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.